Can't hear.
I'm yet to start, so I think we can start now.
Okay.
We are many. We can start the session. Just give me a moment, 1 minute. So, good morning, everyone. For those who just joined, I hope your weekend was great and that we are ready for this week. I believe last week was exciting. Okay, according to me, I don't know what your sentiments are, but I think we covered quite a lot and introduced some of the key emerging technologies. And for this week also, we shall continue on the same note. And by the end of the week, we'll share a poll where you will share your feedback in terms of how the training has been. But that doesn't mean that your feedback is restricted to only at the end of the session. Anytime you feel that you need to give feedback or seek any clarification, the floor or the mic is open. And as a recap of last week, we introduced emerging technologies and saw how they can be used to accelerate the achievement of the 17 UN SDGs. We introduced the Internet of Things, talked about it. We also introduced artificial intelligence, which we shall continue with today. And there are many other interesting topics that we shall cover. And we also saw how the advent of the cloud has enabled some of these applications to gain popularity, because now the cloud has been able to bring closer computing power and resources that were previously not available to the ordinary person. And the other thing we also saw was how these emerging technologies are driving us towards a zero marginal cost society, where it costs close to zero to produce goods and services. And we looked at some examples, and the most notable one was, of course, like, for example, in the music industry, which has totally been changed by these new technologies, such as the internet and the cloud. So last Friday, where we left off was we had introduced what artificial intelligence is, talked about it, discussed it in as far as SDGs are concerned, and the policy framework around artificial intelligence. I shared my opinion. It might not be the right opinion, but it's an opinion that is shared by many people, that there is need for the regulation of artificial intelligence use globally, not just in Kenya. And this is because artificial intelligence will introduce some previously unthought of angles to how regulation should happen. We are now moving away from mostly talking about enabling commerce to happen, but most of it touches on some aspects of human affairs, like emotions and all that, and morality. So the approach would be a bit different. We are not just managing a resource, we are managing a new socioeconomic system. Yeah. So today, I'd like us to continue on the same note and talk about big data. And big data is one of the words, I'm sure, that I would classify as a buzzword that has been thrown around a lot in the last 4 or 5 years. There's a lot of talk of big data. What is big data? How are businesses leveraging big data? How can governments, for example, use big data? And why is there all of a sudden an interest in big data? Is it just a hype? Yeah. So when we talk of big data, we are trying to differentiate it from what is known as normal data or ordinary data. For lack of a better word, the opposite of big being small, so small data. So this big data is essentially data that is either too large or sometimes can also be too complex in terms of how it's coming in or how it's arranged or what it contains. And this makes it difficult for what we have commonly used as data processing methods or storage methods, such as relational databases, MySQL, Microsoft SQL, and Oracle databases. So big data is too complex to be processed or stored using those traditional methods. So big data can essentially not be information that can easily be stored in a database or analyzed within the normal databases that we use. So, which means that for a very long time, it's been difficult to process big data. It was being generated and it wasn't being acted upon, or it wasn't stored in such a way that it can be acted upon. And some people like calling that as dark data, where data just gets generated, it's neither stored nor used for any other purpose now or in the future. Now, what makes big data is because, as we've said, it's high volume, that is a lot of traffic is being generated, and this can sometimes be simultaneously where you have so many sources of data generating this data. A good example of high volume big data is, for example, social media usage. There is a lot of activity currently going on Facebook, and all
Can you guys hear Tom?
No, I can't hear him. This is Victor.
No. He's lost.
I think he's gone off again. Tom, we can't hear you.
Hang on.
can you hear me?
Yeah, you're back now.
Yeah, now you're back. But we lost you on the other slide.
Oh, I'm wondering what's up because my volume shows okay. Okay. So I talked about characteristics of big data. I mentioned, sorry about that. I mentioned high volume. I don't know how far you lost me, but let me just repeat this slide. when you talk of big data, it's usually characterized as high volume. And by high volume, we mean that there's a lot of data that is being generated. There's a lot of data that is being generated, and we are unable to essentially process this data using traditional means, such as the databases that we know today. The reason why it's called big data is because traditional methods of analyzing this data are not applicable or are insufficient to process this large amount of data. So a characteristics of big data is that it's high volume. And the other thing is that because of the many sources of data that are being generated, majority of this data is usually high velocity. And by high velocity, we mean that this is data that is generated sometimes constantly. Yeah, like if you have a fitness tracker, that data is generated constantly. Or if you have a location monitoring system in a vehicle that uses IoT, that is data that is being generated continuously. And by high velocity, we also mean that this data is sometimes generated for immediate decision making. Some decisions on this data that is being generated have to be made in real time. That this data is being generated, what do we do now? A good example would be IoT big data, where sensors are sending in information, and based on the information from these sensors, that information does not need to be stored to be analyzed later in the day. It needs to be analyzed in real time and decisions made in real time also. And this has posed a big challenge, especially in how softwares or analysis systems are designed, because traditionally the systems weren't designed to process this data in real time and make decisions. And we've started seeing new approaches to high velocity data, which we look at and include the ability to stream data. When people talk about streaming, most of the time they usually mean a video or audio. But of late, we are now looking at data streaming as a new facet in which we need to approach big data. In that the analysis of the data is done as it is being received without even sometimes storing it. Yeah. And then the other characteristic is that big data is high velocity, high variety. And by high variety, we mean that this data can sometimes contain This data can sometimes contain, just 1 second. This data can sometimes contain very many variables or information that is widely varying. So it's not just, for example, if you have a system analyzing big data, it's not just analyzing maybe your business processes or your transaction volumes. It could be looking at your transaction volumes, maybe the buying habits of these customers, maybe the buying times of these customers. So there's a lot of information that is being analyzed in big data. Back home, recently when Nakumatt closed, there was a lot of talk of there is need for whoever will replace Nakumatt from the market to ensure that they buy the data from Nakumatt, especially the transaction data that is contained in the Nakumatt smart cards. That information was very valuable, which is true, because if you, I no longer have one, but if you were to take my loyalty card, you'd be able to know what kind of a shopper I am, what I buy, when I buy it, how often I buy it, and you can profile me with that data. Because yes, I might be buying wine, but based on my trends, I am this guy who buys very expensive wine towards the holidays. So that is information. Or I am this guy who rarely buys electronics in supermarkets. So that data is there, it shows. If I have a loyalty card and in the last 5 years, I've not bought a single electronic device, it will show that this person rarely buys this type of goods here. So that is information that can be used to profile me. So people are saying that that is big data that Nakumat's replacement should have bought. Yes, it is data, it is useful data, but it is nowhere close to being big data. Yeah, it was useful data, but it wasn't big data. So the question that is usually in the market is big data just hype, or is it really something that is practical and can be used in real life scenarios? Yeah. Last week we spoke about the hype cycle. You remember the hype cycle that we talked about? And we have a graph down here which shows the hype cycle, the bottom left graph, which shows the characteristics of a hype cycle. And we said a hype cycle is made up of two graphs. One is the hype graph, which is this one, the blue one that is dotted. And the second one is the technology maturity or business maturity graph, which is the green one. Now, I needed to find out whether for real, big data is just hype or just something that actually exists and works. And I went to Google Trends, and in Google Trends, I searched for how frequently the word cloud computing and big data appeared between 2004 and now. Yeah. So I just picked a period of about 15 years. In the last 15, 16 years or so, what has been the trend? And this is what I saw, that cloud computing hit peak in around 2011, thereabouts, yeah? While big data hit peak somewhere around 2014 and has been fairly constant ever since, yeah? And if you look at these graphs, you will be able to see that there's actually a hype curve superimposed here from the two graphs, just similar to what we have here. So big data as a technology itself has matured and is in use, and we'll see use cases. And before then, there was a lot of hype around big data being this powerful tool that can be used and all that. But during that time, the technology wasn't really mature, and the cloud was actually now just coming up, and the adoption of cloud. So the adoption and maturity of cloud is what enabled big data to take root, big data analytics to take root. And I searched to see the average monthly frequency of the use of the term big data in academic and business documents. And this bottom right graph here shows that from around 2011, there was, let's say 2011, there was a surge in use. And as you can see, this is nearly exponential. So this data that I got online actually corroborates that big data is not hype, that it's here and it's working and it's serving very many needs. And we'll see how that is happening. One of the things that is usually asked is, what is the value of big data? Yes, we are collecting a lot of data, and this data is available for us to use, but what is the value? Yeah. And by use of big data, we're actually able to extract business insights from this data. And we can extract information out of this data. And by that I mean that if we analyze this data in such a way that we use non-scientific methods and principles, we can easily be able to accurately do some things, or maybe predict some things. We can be able to prescribe actions to what we need to do. By analyzing big data, we are also able to do an analysis, or maybe a diagnostic analysis, to see what happened. Based on this data that we collected, when something was happening, what actually happened, we can use that. We can also analyze big data to describe things or trends or whatever that data, whatever resulted to that data. And then we can also use big data for what is known as outcome analytics. These methods are actually the different methods that can be applied on big data. So if you have a large data set of big data, you can use that data to predict what will happen because that data has trends in it. You can also use that data again to, based on that data, to prescribe next course of action. Let's do this. This data says this, let's do this. Or this data says this is what is going to happen. That is a prediction. Or this is our data, and when you look into this data, we think this is what happened. Yeah, that's a diagnostic. Or descriptive. Based on this data, this is how we describe this system or what happened. And then outcome is to analyze the outcomes of actions that we want to take. Based on this data, what are the most likely outcomes if we do one, or if we do two, or if we do three? So those are the methods that I use. And most of these methods are usually by use of programs or scripts that are written by data scientists. And as I mentioned, data scientists are actually professionals now. The same way you have a doctor or an accountant or a teacher. So these methods are actually described, and one of them, as I've mentioned in predictive analytics, this is a forward-looking method where you try and focus what might happen in specific scenarios. And you can use big data basically to predict future states, or maybe predict future patterns or any relationships among whatever entities you are measuring. And this, of course, heavily utilizes, other than just predictive, all the methods we've mentioned heavily utilize statistical methods. So a data scientist is essentially somebody who is very well founded on statistical methods and computer algorithms and subject matter expertise. Yeah, and by that I mean a data scientist is not does not exist in isolation. So if you want a data scientist to be able to correctly utilize maybe medical data, it would be easier if that data scientist has a medical background. Yeah. If you want a data scientist to analyze maybe socioeconomic data, it would be advantageous if that data scientist has a background in social economic subjects or areas. So that's very important, that for you to get meaningful insights from the data, the people analyzing the data must be experts at that field from which the data came from. And that is the best way to actually extract meaning. The other method we mentioned is prescriptive analytics. This is also forward-looking. and is essentially usually targeted at giving the possibility of making optimal decisions based on past data for future situations that might occur, or future likely scenarios. Yeah. And then prescriptive is actually also based on probabilistic methods and is used to determine the best solution among a variety of choices that are available. That based on this data, these are the 4 things we can do, but this data says that doing number 3 will be the most useful based on our circumstances, etc., etc. Diagnostic is also another method, and it's backward looking in that you use the data to tell what happened in the past based on the data. Yeah. And because of that, considering you're only relying on that data only, the best way is usually to look for causal relationships and sequences in that data. Then you'll be able to diagnose whatever you are diagnosing better. And a good example of diagnostic analytics is when, for example, though that's not big data application, but a diagnostic analytic example is when doing aircraft investigations. All that black box data, all that flight recorder data is analyzed in such a way that they look for causal relationships and sequences of what happened. The pilot said this, the pilot did this, and then this happened. That is a diagnostic analysis sample. Then descriptive technique. This one takes a lot of time when you are using it, and is also usually derives the least value because you're simply uncovering patterns that you see. You're able to say, this data is telling me this, but you really don't use that data to make future decisions or to choose a course of action. You're simply describing what the situation is. Yeah. And it's often used to compare in comparison cases. You can use big data also for comparative analysis. And in descriptive analysis, the aim is basically to look for a pattern. Like if you have a lot of data on harvesting in Kenya, and you have a lot of data on rainfall patterns in Kenya, you can be able to use descriptive analytics to see whether there's a relationship between rain pattern and agricultural activities and maybe harvesting. So that would be one way, yeah. The last one which you mentioned is outcome analytics. And in outcome analytics, these are like a combination of the ones we've described previously. And this method is usually aimed at helping, for example, in an organization, you might be able to know your customers better and learn how they use your products. And by that, of course, it means you need to look at the previous data, historical data, basically. You also need to look at the real-time data currently. What are these people doing? What did they do in the past? So what are they going to do next? Yeah. So if you have that kind of data, then you can be able to do things to analyze, especially in business environment, to do things like consumptive analytics, where you're able to focus your energies on behaviors that lead to the outcomes you want. Yeah. So if you analyze your data and realize that majority of the customers who visit my website, who browse this type of tool, always end up buying this type of tool, this other type of tool. So if people who are on my website searching to buy electric drills, people who are in Can you hear me?
Yes.
Okay. So this method, for example, is used a lot on e-commerce websites, where you might find that you're buying something, and then there's an offer on something else, and most likely you are like, "Wow, how did these guys know that I also need this?" It's because of outcome analytics based on your previous history and your current real-time behavior. We can modify your current behavior for us to get a desired outcome. We can modify your current shopping behavior or browsing behavior right now on an e-commerce website to ensure that you buy more, etc., and so on and so forth. When it comes to big data analytics, there's usually a lot of questions from people who look at big data, especially those who hear it for the first time. They're like, then you're busy talking about outcome analytics or descriptive analytics, but how do I do that? Today, I am seated here as the head of maybe as the IT head in this organization, and we have all this data. Where do I start? Yeah. So the point is that these are actually real systems. They're actually real systems existing in the cloud that utilize the existing technologies that we've discussed, like the cloud. And businesses are actually using big data analytics in the cloud to do very many things. And I have a video here which shows how big data analytics is done in the cloud. In this case, we're using a video from IBM. But whatever IBM does with big data, the processes are the same. The systems might be different, or the approach might be different, but the processes are the same. Yeah. So let's watch this short video that will take us through that.
This is Raj. He's looking to shape up after an indulgent winter. Raj searches for healthy living and sees an ad for health and fitness products from a local department store where he used to shop. Raj downloads their health and living app and registers his old loyalty card, which unlocks his basic data and preferences. With a few swipes, the app seems to intuitively predict what he's looking for and his style of buying. It doesn't seem like a normal shopping app, but more of an experience that relates to him. Now, let's take a look behind the scenes at VT Living and see how they are working to become Raj's trusted health advisor. Sarah, VT Living's app developer, is the brains behind the new app that Raj downloaded. Initially, all he could have done was search for products. Sarah was frustrated because she had no way to integrate customer data, like the information on Raj's loyalty card. She also wanted a better way to predict what products or services he might need. Sarah has heard good things about IBM Bluemix, a cloud-based platform that enables developers to rapidly build, deploy, and manage their applications. On it, she finds a cloud-enabled database as a service called Cloudant. Cloudant can serve as the data platform for her app. Cloudant also allows Sarah to build an app that will scale quickly and support millions of users and interactions. Everything she needs in order to integrate enterprise data into the app is offered on Bluemix. For instance, Raj's past shopping habits on vtliving.com, or information from a heart rate monitor on his instrumented watch. With a few clicks, she easily incorporates this data into her app. Sarah was able to do this because of a self-service data refinery in the cloud called DataWorks, which cleanses information as she works. It's simple to use and secure enough to protect the most personal data. Sarah can enrich the app further by analyzing Twitter data available via Big Insights for Hadoop to improve the app experience for millions of customers globally. Next, Sarah moved the mobile data from her app to an easy-to-use data warehouse called DashDB to store her large amounts of data and perform analytics. Because the warehouse is cloud-based and not limited by server space, she can expand and scale her analytics as she receives more sources and greater amounts of data. Sarah uses analytics to accurately personalize Raj's experiences by matching his searches, location, and other fitness history against VT Living's existing offerings. All of this allows her to build her app to not only use data-driven insight, but also to create and share data with her colleagues in real time while customers interact. Will, the marketing director, is known for being very creative, but wants to know that the offers from his campaigns are refined for each customer, whereas previously, he's relied on intuition. To better target his campaigns, he signs up for a new cognitive analysis service called Watson Analytics. And Watson Analytics offers powerful visualizations of customer data. Will can ask questions in natural language and receive guided answers that reveal important drivers of customer behavior. Will doesn't have to wait for his analyst to prepare data. Watson Analytics assesses data quality on the fly and gives a confidence rating for his results. Now, Will can quickly show his boss how campaigns are performing across customer segments, and because it's on the cloud, his whole team can access the information from anywhere on any device. Behind the scenes minding operations is Colin, VT Living's data analyst. He used to spend 80% of his time just searching for data. He's now using predictive customer intelligence on cloud and can spend time finding patterns and insights for his team. Colin's job is to create predictive models that make sense for all data coming from customer touchpoints and services. Data pulled from Sarah's apps, websites, and point-of-sale systems are used as inputs so Colin can combine historical, social, and contextual data to discover predictive patterns. Colin's models can tell Will in marketing which are the top 3 options out of hundreds of offers based on Raj's actual behavioral patterns. They incorporate cost-benefit financial information as well, so the CFO will stay happy. And since they were created on the cloud, all of these personalized customer interactions can happen in real time when Raj is ready to make a purchase. Working together, Sarah, Will, and Colin find clues about how to respond to Raj's real-life needs. They integrate data from traditional backend systems, social media, and devices to better capture and respond to him. Since downloading Sarah's app, Raj has bought several health and lifestyle-based gadgets to enhance his workouts. Each is connected to VT Living's app and generates data that Sarah, Will, and Colin can continue to reference. By sharing select personal data with VT Living, he enables their team to provide him a much more robust experience. The more he does, and the more he connects, the better his experience and the more on target the recommendations he receives. It's a win-win.
So that's actually a video from IBM showcasing their data analytics services that they offer. And my takeaways from that video is, number one, it seems that Raj, this guy who was a subject in the video, has given up a lot of his privacy for the sake of convenience, yeah? Because an organization like the one that is being used there, VT Health, has access to a lot of Raj's data. And they can analyze that data to make better decisions about what to sell to Raj, yeah? And for that to happen, some level of privacy must be ceded by Raj, yeah? A summary of that video would be, for example, Raj has been buying products from VT Living, and VT Living has also been suggesting products and services to him. But all of a sudden, on his social media, we see that Raj is talking about partying, is talking about drinking till very late, is talking about being on holiday. He's actually gone to a holiday because his Fitbit and location show that he's not where he normally lives in, and is actually somewhere near the coast. And most of the time, whereas previously his Fitbit had data of maybe 15,000 steps a day, for the last 5 or 6 days, maybe they're just 200 steps. Yeah. So that says something about Raj, that Raj is no longer exercising and that Raj is on holiday. Yeah. And maybe one day Raj might tweet and say, flight delays. I hate this airline. So it means Raj is actually coming back from holiday. So when Raj is back, VT Living is ready with the data that it has concerning Raj, because now we can target products that are aimed at his circumstance now. Raj hasn't exercised in the last few weeks. Raj overfed while on holiday, so we know what to target to him, etc. So that data that is being generated in Raj's life, maybe from his social media, from his phone, from his wearables, from his transactions online, that is big data. For Raj alone, that is very little data, but can you imagine now VT Living gathering data for let's say 5,000 or 10,000 of their customers in real time? That data can now be analyzed to know that these are the kinds of products that we need to target Raj with. If on the other hand, Raj has always been talking about frustrations about his training kits or his training equipment, then that information can also be analyzed and used to offer products and services that are targeted towards Raj. Yeah. So that's what that video is talking about, and that there's power on the cloud currently to be able to analyze that data and make those decisions. And they mentioned about Watson Analytics. Watson Analytics is basically IBM's AI service. Microsoft Azure has its own service. Amazon has its own service. IBM has its own service. So with Watson Analytics, what they're essentially doing is that they're applying AI to big data insights for the purposes of making decisions. Yeah. And by that, it gives this organization, VT Health, a lot of power to leverage on the data that is the big data that is being generated by their customers, to be very specific and targeted to them. Yeah. Now, previously we've experienced this online, where when you're browsing, you are bombarded with adverts that are tailored to you. So if you're always talking about shoes, or if you search for shoes online, and you go to Facebook, the adverts that will be there on Facebook or even on Google will be towards what you commonly search. If you are always searching about cars, trying to maybe search online to buy a car, majority of the ads that will come there will be mostly from car selling companies or people who sell cars, yeah, or car selling websites. But that is just online. That is a prediction based on your online behavior. Now, if we move a step further and also use data from your offline life, like from your wearable, your location and all that, the personalization can even be much better, yeah? And that is what you're talking about, big data analytics and its application to normal business operations. Maybe just to come back on the issue of privacy that Raj has given up, it is always a balancing act between how much privacy you need to give out or to seed vis-a-vis how much personalization you get. Of course, you have the option of not allowing these devices to share your data, but it gets less personalized, yeah? So the assurance that is usually being sought by most people is, how will you guys ensure that my data is not misused, for example? And I gave an example the other day of my Fitbit data. You can know that I do 15,000 steps every day. That info might not tell you much, yeah? But it can be used by an organization to know that I exercise, yeah? You can know that maybe I take these 15,000 steps between 4 p.m. and 5 p.m. every day. That is a second piece of information. which might not really tell you much in isolation, but combined with the first bit of information, it's forming something, yeah? And if you add an additional third piece of information about the location, you know, somebody takes 15,000 steps a day, it takes them between this time, and this is where he walks. You can, with very good certainty, identify that person. Physically, you can sit somewhere and watch him pass, or her, and know that is so and so. So this data that has been collected by my device, how do I ensure, or what are the collectors of this data doing to ensure that my anonymity is preserved, that no one can really put two and two together and breach my privacy? So that is where now the analysis of metadata comes in that some systems analyze what is known as metadata, not the actual data itself. And it's always encouraged, if you can use metadata, then you use it for analysis. And what do I mean by metadata? Let's take an example where your call records, let's say at a mobile operator. We know the mobile operator knows when I make phone calls, yeah? They know how long I make those phone calls, when I make them, to who I am making those calls to, how frequently I call certain numbers. All that data is there, yeah? There could also be data which is able to maybe go a step further in some countries maybe, but not in Kenya, where even some of your communication, what you said, can also be stored, yeah? What you say can also be stored. So how do you differentiate between storing actual data and metadata? That is where now regulation comes in that it might be a law in a certain country that if an organization, for example, is collecting the data that I mentioned, if an organization is collecting the data that I'd mentioned, then there are specific laws to prevent metadata analysis that can lead to breach of security. For example, in the 3 sets of data that I mentioned, it might be that these 3 sets of data should not be analyzed in such a way that it is obvious that this person's privacy can be compromised. Yes, you can gather data on how long this person walks, the number of steps. Yes, you can gather data maybe about the location of this person. Yes, you can gather the data about when this person walks, but do not combine these sets of data. Or if you combine them, you should encrypt them when you store that information so that it is not easily accessible, yeah? So when it comes to big data, the advantage that we get is that, as I've mentioned, organizations are generating a lot of data today. Individuals are also generating a lot of data, and a lot of this data is being stored online. And people can dig insights into this data and make very accurate predictions. There's this common story online, I think you can search for it, where a supermarket, through the shopping behavior of one of its customers, was able to accurately predict that this woman was pregnant before she even knew. Can you imagine that? So she got a congratulatory message from the supermarket that she's pregnant, yet she didn't know. How did the supermarket know this? Because they have all her past data in as far as shopping is concerned. And based on her recent data, she started changing what she buys. All of a sudden, she's not buying scented lotions. She's buying fragrance-free lotions. All of a sudden, she's buying foods that are associated with the cravings and all that. All of a sudden, she's spending money on new clothes or something. So they were able to predict accurately. And it's actually a very famous case. You can read about it. I think it was Walmart. I can't remember the name, but the supermarket was able to use big data to know more about their customer than the customer did about themselves. So where is the line drawn there? Where does regulation or self-regulation come in? Yes, they knew that this customer was expectant, but was it within their powers to tell her that? Was the approach the right way? Yeah. So there are all those questions that arise when it comes to big data, but big data is just that. It will give you insights, but without these insights being actionable, then they're just that, insights. So the big value that businesses are drawing from big data analytics is the insights they get. Yeah. Can you imagine the amount of big data that an entity like NTSA would have if they monitored just 5 parameters in every public transport vehicle? Just 5, not many, just 5. Maybe the speed, maybe adherence to the route, maybe how many stops they make in that route, maybe from town to Kiambu or town to Rongai or town to Athi River. How many passengers get in and out of the matatu at every stop. Yeah, they can be able to know this matatu was overloaded, or they can get a lot of info on that. They might, for example, based on the data gathered by these devices, discover that, number one, the matatus are spending a long time at the stage filling up. Then number two, the matatus are stopping frequently in each and every stage. Yeah, that data might not be useful to me as a common mananchi, but that data can tell NTSA, by the fact that these matatus are spending very long on stage, it means on this route we should not register, we should not license 33 seaters. We should only do 14 seaters, because 33 seater takes very long to fill up at the stage, and this is inconveniencing travelers. Yeah. So on this route, not 33 seaters, only 14 seaters based on this data. So NTSA can make an informed decision based on analyzing big data from matatus. They can, for example, realize these matatus are stopping too frequently in very many places that are not designated stages. It means people need to alight there. So what can NTSA do, or work together with the road authorities, maybe to put stages there? That is data that NTSA does not have. NTSA cannot tell you which matatu stops where and for how long and at what time. But with big data, that data can be crunched. So all that data from all matatus, they might say that every matatu register, the same way they say must have a speed governor, it must meet these certain compliance requirements. They can also say it must have these sensors that will collect this data for us. And then all this data can be sent to the cloud. For example, NTSA might decide to use IBM in that case we saw, or they can use maybe AWS or Microsoft. Automatically that data goes to the cloud. That data is analyzed, and insights like we should not register 33-seater matatus here, or we should work with the KENHA to introduce more matatu stop stages along this route. Yeah, or matatus from this route are not using the designated road, they're using shortcuts and panya routes through estates. So that is info that NTSA that currently doesn't have. And this data can be analyzed and incorporated even into the licensing system. And there's a lot that can be done. For example, if you look at NTSA and how they can apply big data. Is there any question up to there, up to where we are currently? So the question then is, how much data do I generate as an individual? Yeah, and we've covered that. My mobile apps generate a lot of data. When I go to supermarket and shop and maybe use a loyalty card, that is data that is being generated. Even if I don't use a loyalty card, if I paid by M-Pesa to a till number that belongs maybe to Naivas, that is data. It shows that I shop at Naivas. And that M-Pesa message has a timestamp. I shop at Naivas at this time. I shop at this place at this time. So a lot of insights can be extracted there to get my shopping patterns. My social media, what I say there, what I post can generate a lot of insights about my state of mind or my desires. Yeah. My fitness tracker, as I've said, can generate a lot of data and location services in mobile, in fitness, in wearables. Mobile call data, all that data is available. And in a 24-hour period, I generate a lot of data that might not make any sense to any organization. But if combined in a clever way by a business, they can be able to form a sort of mental or digital copy of me and know that from this data, Thomas is this kind of person, or Thomas is this kind of spender, or this kind of shopper, or he's this person who maybe likes taking holidays, or is a flashy kind of person. So we will sell him flashy things, and so on and so forth. So all that data can be used to make business decisions and help organizations. There's another video I'd like us to watch, which shows what systems are actually there on the internet or on the cloud that can be used to analyze data. Because one of the questions maybe one of you might be having is, okay, now that I understand what big data is, where do I start? Where do I log in and register an account? And what tools do I need to select to analyze this data? And how can we use this data effectively as an organization? So this video will show how, or the data flow across the Amazon cloud. It's very similar to the video we watched on IBM, but that IBM video was simply focusing on what the business gains from it. But this video more so focuses on you as the person who wants to implement data analytics on the cloud and utilize artificial intelligence. What options are there for you? How do you go about it? How is the process from a bird's eye view, from the time that data is generated at the supermarket to the time we make a decision to target this customer maybe with a certain product or understand this customer better? So let's watch this.
Hello, my name is Jorge Lopez.
And I am Carlos Escapa. Together, we work with AWS's worldwide network of big data and machine learning partners.
Advanced analytics and data products have become a primary source of competitive advantage and value generation for companies. But transforming data into a valuable corporate asset can be a complex process that entails dozens of technologies, tools, and environments. AWS provides a broad portfolio of managed services for data analytics, along with a vast partner community to help you build virtually any big data application in the cloud. However, customers and partners often ask us to show them the big picture, how to put all these pieces together so that they can explain it to all their stakeholders.
We have created a poster that depicts the flow of corporate data when used for advanced analytics and machine learning. In this video, You will learn how to use the poster and build a narrative that can be used in cross-functional meetings involving both technical and business stakeholders, from developers and data scientists to line of business and senior executives.
Information comes from different sources in a broad variety of formats. Some data are highly structured, like the data found on traditional CRM and ERP systems. Unstructured data, on the other hand, does not conform to a predefined schema. Images, videos, phone calls, and emails are good examples of this. In between, there's semi-structured data, such as logs from connected devices, IoT sensors, and web servers. This large variety of formats and sources often means that a lot of this information goes untapped. This is known as dark data. You simply cannot make every form of data available for data science and machine learning using traditional architectures. That's why many organizations are transforming their approach and adopting a data lake architecture on AWS. A data lake fits on data. You can move data in batches using a tool such as AWS Glue, which extracts the information from multiple sources, often performing some transformations such as joins, aggregations, and loads it into your data lake, making it available for analytics. Increasingly though, organizations need to take immediate action on data that are generated continuously from IoT sensors, social media, or wearable devices. Amazon Kinesis allows you to easily collect, process, and analyze video and data streams in real time, so you can react quickly to new information. You can run simple SQL queries on streaming data to provide real-time alerts. Or you can use deep neural networks like Amazon Recognition and Transcribe to instantly tag and categorize images and videos even before they land in your data lake. A data lake allows you to store massive amounts of data into a central repository, so it's readily available to be categorized, processed, analyzed, and consumed by diverse groups within an organization. The large majority of our customers use Amazon S3 as the storage layer for their data lakes. S3 provides unmatched durability, availability, and scalability, as well as the most partner integrations. But of course, storing data is not enough. Organizations need to discover and catalog their data, making them easily consumable for analytics. Using AWS Glue, you can automatically crawl your entire data lake and construct a single view across all the data assets. You can use tools like Amazon Athena to run interactive queries directly against your data lake using standard SQL. You can also code and run sophisticated processes and algorithms using big data frameworks such as Hadoop and Spark with Amazon EMR. All this without moving your data.
Data lakes enable data scientists to access a single source of truth and pipeline it into Amazon EMR or Amazon SageMaker for predictive and prescriptive analytics. SageMaker is an integrated development environment with a complete set of tools to develop, train, and deploy machine learning models at any scale. It provides hosted Jupyter notebooks where scientists can iterate quickly with a framework of their choice, accessing CPUs or GPUs seamlessly, depending on the algorithms and the data volume of each problem. There is no need to install, configure, deploy, or tear down compute clusters. Terabyte and petabyte scalability is built in. In addition, SageMaker provides a fully managed elastic environment that can be dialed up or down automatically. Amazon SageMaker is the ideal place to host inferential data products. It is integrated with AWS Greengrass, so machine learning models can be deployed automatically to thousands or millions of managed IoT devices. Today, AWS and its partners have the broadest set of tools and practices available to data engineers and data scientists alike to facilitate advanced analytics and the monetization of corporate data, fully leveraging AWS's security, scalability, and cost advantages. You can download a copy of the poster at the URL listed in the description.
If you would like to learn more and try out some of our solutions for yourself, check out the AWS Solutions page.
Now, let's go build.
So I think that was a very good introduction on how someone can start out to build data analytics tools and leverage big data in their organization. And it shows that it's not a difficult process. Within a day, within hours, you can be up and running, and you can deploy machine learning models. In the example they've given, an organization can collect a lot, excuse me, can collect a lot of data and store it in a data lake. Data lake is basically a place where you store unstructured data. It's not a database per se, but it's like a dump of all your data that you're collecting. All the IoT devices that are out there that you're monitoring, they don't directly write to a database when that data is sent up to the internet. It's usually often thrown to a data lake. And then it is in the data lake that now you can write scripts or write machine learning algorithms to either learn from that data and extract insights out of it. We saw how machine learning works. You can also use tools that are available on the cloud to format that data and even store it in a database and use the normal SQL-based query languages to analyze this data the way you analyze normal data that you collect. The other thing that we've seen in that video is that it's not really rocket science to do big data analytics. All you need to do is to be able to understand the fundamentals and the tools that are available and how they are used. For example, if you want to do big data analytics on the Hadoop framework, for example, or the Spark framework, or Apache Spark, for example, you definitely need a data scientist or a data engineer who's conversant with those frameworks. And the selection of either using Hadoop or using Apache Spark would be dependent on the strengths and weaknesses of each approach, because each has its own advantages and disadvantages. So it's very easy for an organization today to utilize its data assets in as far as helping the business improve. And as you've seen, AI is a very big component of big data analytics. One reason why big data analytics has become popular, as we mentioned, is because of the cloud and AI. The cloud gives us the compute and storage abilities and the analysis abilities, and AI is able now to give us the insights into this data. You can write a machine learning system, for example, that is able to learn the behavior of your customer. For example, all the data that you collect, you can write a machine learning routine that maybe is able to tell you when this customer makes a significant move. In that case we saw for Raj, you can write a machine language system that says, can we know if any of our customers travels for more than 300 kilometers away from his average location area? My average location area, of course, is Nairobi. I'm mostly in my house. Sometimes I'm at the mall in Galleria. Sometimes I'm at the mall in Capital Center. Sometimes I'm in Westlands. Occasionally, I might end up in Thika, maybe once a month. But my normal operating area is Nairobi. So on average, you can write a machine learning system that says, if any of these people we are monitoring their location is in the coastal region, for example, then we take this action. Yeah, maybe we have a restaurant there, we have a massage spa. Maybe this person, because he's our customer in Nairobi, if at any time we see is in the coastal region, let's throw that 20% off offer discount to them for the services that we offer in Mombasa, and so on and so forth. That is one way in which machine learning can be used, and machine learning can now be trained to learn with time, that by the fact that this person is away from their place, they are at the coast, their location is very close to the beach, and based on social media posts by people who are around this location, there are so many photos of people swimming, this guy must be on holiday. High chances that he's on holiday. So what do we do about that data? that's just an example of how machine learning can be used. And many other applications, as I've given, for example, how NTSA can utilize it. Organizations such as yourselves, how do you utilize big data analytics in your operations? There's a lot of data that maybe is gathered by remote systems. That data maybe right now is just being written into a database. It might not be very large, but in instances where that data grows so large, or in instances where you implement IoT, and now that data needs to be analyzed, then it's not as hard. And organizations are already doing that to great benefit. Now, as I mentioned earlier, these things are interrelated. For example, we don't just analyze big data and use AI to gather insights, but we can take action based on that data. We can also use other tools to enhance our ability to make decisions based on that data. And all those tools are on the cloud and available. And when you talk of emerging technologies and big data and the SDGs, a lot of data that is available today, especially like on populations, on disease prevalence, on education levels in various counties, etc., etc. Or the government, maybe for example, the PS in charge of public service might decide to analyze all the biometric data for all the government staff in all offices in the country. That is a lot of data that comes in every day. And that data can be put on the cloud and insights can be extracted. Just knowing that people report to the office at 8, that's not a really good insight. But insights can be drawn. For example, with that data, you can know that when it's nearly budget time, then a lot of people in the accounts office always come very early. Or when it's near exam time, or when it's near elections, people in the IBC office, this is their movement pattern. And that data, plus other sources of data, can be analyzed to make decisions. And there's an example that I usually like giving people concerning data, that if you look at Google, how it analyzes its data about you, Google is not interested in knowing that Tom went to Westgate Mall yesterday. That info is useless to Google, yeah. But Google is interested in knowing that there were 300 people in that mall yesterday, and majority of them came in the afternoon. That is data that they can sell, yeah. The other day, Google released info saying that about traffic in malls has increased by 35% after the COVID, the first week when COVID lockdowns were announced. And the second time it was announced, people started now going back to their lives as normal. And this data was released by Google saying, yes, it's true, life is going back to normal, and we've noted that 35% increase in number of people visiting malls in Nairobi. That data is online. You can search for it in any news website. And that is what is useful to an organization. The fact that Google counted me as one of the 35% increase is immaterial to Google, that one of those people was Tom. Yeah. But at a very high level, the metadata that was used to analyze that is useful. The government is now able to know, oh, okay, are our interventions working or not? And that is just one example of how big data, in this case, location data, can be used to give insights into what is happening. So that is what I wanted to briefly touch on big data. We would I'd like us to take a break, maybe a 5-minute break, and then we can convene here at 1:45, midday, so that we can continue on the next section. The next section will be talking about conversational AI. This is very interesting. So see you then. Unless there's any question, we can take a break. But you're free to ask questions as the rest take a break also. So I think we can continue after the break. Can we continue? I guess we're all back.
Yeah.
Okay. So we've talked about big data and how it can be analyzed. Now, the same approaches that are used in big data machine learning, where a lot of data is analyzed by use of machine learning technologies or techniques. Let me not call them technologies. Machine learning techniques, such as deep learning. If you are to loosely define machine learning for the purposes of AI, you would say that machine learning is advanced pattern recognition, that it's all about recognizing patterns in speech, in what people do, in what they buy, in everything. Yeah. So the ability to recognize pattern. And the use of neural networks has been found to be very good in pattern recognition in large data sets. Yeah. For example, if you were to throw all the conversations that have been held online on social media into a machine learning system, some of the patterns that can be gotten from there is intent and meanings. What do people mean when they say this? What was the intention of this person when they say this? Yeah, because that has been the challenge with computers. Computers can interpret what you're saying, but they might not understand your intention, which is something that had been a preserve for intelligent human beings for very long. Now, because of that, machine learning has been used very well when it comes to pattern recognition in terms of photos. For example, facial recognition software by Facebook is actually more accurate than human beings in recognizing faces. Yeah. And that's why sometimes when you're on Facebook, you see a suggestion that you're about to be tagged in a certain photo, because the Facebook recognition algorithm has known that is so and so. Or when you try tag people on your Facebook page, all of a sudden it gives you the suggestion as the top one. And that is most of the time the person that you wanted to tag. And all that is because of facial recognition. And facial recognition of Facebook is so good to the point that it can recognize a face even with part of the face available, or when the person is looking to the side. You don't have to be facing it, the camera like a passport size photo. You could be facing to the side, you could be facing up, only part of your face could be visible due to maybe wearing a mask or something. And Facebook is able to recognize that. And image recognition together with speech recognition has made very large advances in the last 4 years or so. Yeah, to the point that we are now able to design systems that can converse with human beings, that computers are now able to converse with human beings by use of artificial intelligence, because for the first time, computers can now understand intent. Yeah, like when you say I'm hungry to, for example, Amazon Alexa, it won't ask you how hungry are you. It might know your intent is you want to order food, because last time when you said you were hungry, you went ahead and ordered food. It can also understand intent in terms of context. Yeah, like if you go to Alexa and say, Alexa, place an order in Naivas like last time. That is context. You need context. What was last time? when was last time, and what was ordered last time, and where was it ordered. Yeah. So conversational AI is basically the ability of computers to understand, process, and even respond to human conversing to them. And this conversation can either be by voice, you can be talking, the same way we saw an example, we talked to Google, Google Assistant on my phone asking for traffic, or it could be text. For example, chat in WhatsApp, in WeChat, in Facebook Messenger, yeah? And these conversations usually happen by use of chatbots. And what's a chatbot? A chatbot is simply a program, a computer program that is written, and it has an uncanny ability to simulate and even successfully carry out conversations with human beings. And this can be via text, via audio. So you might talk to it and it responds to you by talking back. You can type in and it can respond to you, yeah? And as I've said, deep learning has really catapulted conversational AI into the mainstream. And there is a technique called NLP, natural language processing, which is used by computers to understand language in terms of context and all that. Majority of us have interacted with the conversational AI systems from maybe a hobby or amusement point of view. An example is Siri. Majority of the people who have iPhones use Siri maybe just to search a few things here and there, and maybe, or even ask it foolish questions like, Siri, are you married, or something like that. So that was the initial use. But of late, we are seeing, due to advancements in AI, those systems are now capable of conversing with us. And that ability to converse with that is now being hailed as one of the most radical ways in which AI can be applied today in the market. Yeah. Conversational AI, I would say, is the first large-scale deployment of AI to the masses. That majority of the masses will know or will interact with the AI in a big way when it comes to conversational AI. And today, even when you look at small kids who know that they can talk to Siri or talk to Google Assistant, prefer talking to it than typing in, yeah? And businesses are also realizing the potential that conversational AI had. The other thing is that when Apple bought Siri from the company that had made it and put it in the iPhone, Apple had several years lead with Siri, but they really never thought much about it, because to them it's just one of those nice things to have on your phone. But other organizations such as Google have seen a lot of potential, and Amazon. And even as we speak right now, as of last year, that is December last year, about 35% of homes in the USA have an Amazon Echo. Of course, that means it has Amazon Alexa in it. And in the UK plus Ireland, before Brexit, it was about 20%. That 20% of homes in the UK have Amazon Echo, Amazon Alexa. And this shows that Amazon realized the potential of conversational AI very early enough. So Siri, Amazon Alexa, Google Assistant, Samsung Bixby are all conversational AI interfaces. Then the question is, why is the interest? For example, why is Samsung interested in conversational AI? Because in a few years, if you have a Samsung microwave, for example, you can simply say, microwave, defrost for 5 minutes. Right now, if you tell me to defrost something, it will take me a few seconds of trying to guess which button to press on the microwave or for how long. And I might not know how long I need to defrost a chicken compared maybe to vegetables. So with conversational AI, I can simply say, microwave, defrost vegetables, or defrost half a kilo of vegetables, or the system itself can weigh. So when you say defrost chicken, it can know, oh, this is a 2 kg chicken. This is not a 1 kg chicken. And for this, I need to use this amount of power for this period of time. And it automatically does that for you. Or at the moment, we are seeing adoption of conversational AI in IoT control. Majority of the domestic IoT, where you can turn off lights and maybe heating systems using IoT, are actually being controlled by conversational AI interfaces. So today, by use of Amazon Echo, you can, for example, say, Alexa, switch off the sitting room light, and it will do it wherever you are, yeah? Or Alexa, how much water is available in our reserve tank, and it can tell you. All those things are powered by IoT. Of course, there must be a sensor in your water tank which measures the level of water or the quantity of water, and so on and so forth. So the use of conversational AI has attracted a lot of attention in the industry. We are seeing companies like Samsung also coming into the foray with the Samsung Bixby. I think if you have the latest Samsung phones, it has Bixby, which is basically a conversational AI interface, just like Siri. But Samsung is aiming at making it the de facto interface for controlling appliances in the house. So you might have maybe an LG washing machine, but you should be able to control it using, for example, the Samsung Bixby. Or you might have a Samsung TV. You should be able to control it using that, or even controlling it using Amazon Echo. These days, majority of the new domestic appliances that are coming out, you'll see maybe there's an Amazon logo somewhere, compatible with Amazon Echo, or compatible with Google Assistant, or compatible with Samsung Bixby. So that is because that is the new user interface. You no longer need to go and press buttons in front of a device to utilize it. That is the new user interface. You simply speak to it. If you are seated in the office right now and you want to, maybe your washing machine to do its run, all you need to do is speak to it. No need of setting timers or anything. Alexa, turn on washing machine for a 4 kilogram load, or for a 7 kilogram load. Then it will do everything from there. Previously, you had to go and punch in the kilogram, you needed to set the time, you needed to say whether you wanted this to be dried or what. It was a process. It is a process still, but that is being simplified by use of conversational AI. Now, if you take this a step further and look at a scenario where that person in rural Kenya is able to converse with appliances and tools using his mother tongue, then we are talking of a radically new way of life, yeah? If my grandmother back in rural can operate a drone by simply speaking to it, then we'll usher in a new age. Right now, of course, you need to be skilled to know how to fly it and all that. But if a farmer can simply say to a drone, do 1, 2, 3, or spray the fertilizer or spray the pesticide, and then it does it, then we are reaching an area where we can be able to interact with the digital world using our voice. Now, when it comes to conversational AI, this is the system and the technology behind it. But at the front of it, how do we interact with it? Of course, we interact with it using bots and intelligent virtual agents. And these are usually presented to us in our familiar environments, in WhatsApp, in WeChat, in Telegram, in Facebook Messenger, yeah, and we'll see examples as we go on, yeah. And there are many organizations now that are realizing, wait a minute, this is big. How do we get a piece of the pie of this? It is estimated that conversational AI will be one of the biggest applications of AI in our daily lives, where we are able to talk to devices, talk to equipment, cars, talk to systems. For example, like today, with the use of Oracle conversational AI interface, Oracle has designed a conversational interface where you can query data by speaking to the system. For example, if you have an Oracle like IFMIS. IFMIS is an Oracle database system, yeah? The government IFMIS. So instead of going there to query about, for example, how many tenders were issued in relation to health, you'd need a lot of expertise to extract that data. You need to know where to click, yeah? But with conversational AI, businesses and organizations can simply talk to that database. For example, show me the top sales in the last 1 week per region. Then it responds. Like you can type that actually on WhatsApp on an Oracle connected chatbot. For example, let's take a case scenario of the organization where you decide we are going to have our HR system available on WhatsApp. How are we going to do it? You will need to have your HR system, the ERP that powers your HR systems. You will need to have maybe your insurance agents or maybe medical insurance company system. All these systems will need to talk to the Oracle conversational AI assistant, and the Oracle conversational AI assistant will present this info to all the staff in your organization via WhatsApp. So all employees need to do is save a particular number, maybe 0731444221, for example. And with that number is now linked to the Oracle interface. So when I'm at the hospital and I'm wondering, what is my limit on this policy? I simply open WhatsApp, the CAHR assistant, and type there, what is my limit on my outpatient? Immediately, it will query all the databases and come back to you. And it won't just give you a number, 4,500. It will actually talk to you like a person. Thomas, the limit to your insurance cover is 45,000 and it expires on 30th of June, 2020. You see, that is a rich experience. It would have taken me another half an hour or so to call the HR assistant in the office and ask the same question or log into a system. All I needed to do is go to WhatsApp. I can still go on WhatsApp and say, how many leave days do I have? Or who in my department is on leave? Then it can tell you, Mohammed is on leave, Etiko is on leave, Rose is on leave. All that is extracted from the system, straight into your WhatsApp. That is the power we are talking about, that organizations are able now to use conversational interfaces such as WhatsApp, such as Facebook Messenger to operate. And we'll see more examples as we go on. Now, because of that interest, businesses, the big tech players, have their own conversational AI interfaces. Most of you, if you use Microsoft Windows, you've seen Cortana, Microsoft Cortana. Microsoft Cortana is an AI interface that can be used by organizations in a similar way as I've mentioned. So an organization can integrate Cortana into their ERP system, for example, or their HR system, or whatever system they wish to interface to. And Cortana can become an interface still through WhatsApp. You can still have it maybe through Facebook Messenger. You can still have it through Microsoft Teams. You can still have it through Skype, whatever interface that fancies you. Microsoft hasn't been very keen in the last 3 years on Cortana, but as of last year, with what is happening, they started gaining a lot of interest in it, and some work is going into it. But they could be late to the party because Amazon is way, way, way ahead of it. And Amazon's conversational AI interface engine is known as Amazon Lex, L-E-X. Now with Amazon Lex, you can interface to WhatsApp, you can interface to Skype, you can interface to WeChat, to Telegram, to Facebook Messenger. And you can also interface to Amazon Alexa. Amazon Alexa is one of the ways in which you can interface to Amazon Lex, which is the AI the conversational AI engine that Amazon runs. So there's a difference there. Alexa is one of the ways in which you can use Amazon Lex. Then there's Google Assistant, which is one of the ways in which you can use the Google NLP engines. There are several. The latest one that they developed is called Google Meena, M-E-E-N-A. And what Google Meena does is that it is hailed as the most advanced chatbot in the world at the moment. It was released early this year. Google Meena's capability are very close to human capabilities in terms of conversation. And it is the only chatbot that can maintain open-ended conversations. As in, you can talk with it anything. Today, you might decide to talk about Mandela, then divert a bit to how many BMWs in South Africa, then again to Zuma, then go and talk about Nigeria. Then after that, we come and talk about politics in Kenya, and then discuss about COVID. It will keep with the flow. Yeah. So that is how advanced these systems have become. Another one is Samsung Bixby, which I've mentioned, which is Samsung's foray into the conversational AI space, where they want to say, when it comes to home appliances, we want to be the guy to go to. But then again, they're facing stiff competition from Amazon Alexa. Now, Alexa is available on Amazon Echo devices, which are basically speakers, home speakers. The other one is, of course, on the enterprise side, there's Oracle and there's SAP, and there are many others also who are also playing in this space. Many of the ERP systems are also realizing the power of conversational AI interfacing to these systems, where the traditional way of querying those systems is now being replaced in favor of conversational AI, because that gives more power to the end user to extract meaning and insights into data. For me to go into, for example, a company's sales database and extract insights, I need to work on that data. With conversational AI, I simply need to say what I want. What is my intention? I want to see last week's sales performance in a line graph, ordered by salesperson, or ordered by region, or ordered by product. And just like that, it's done. No need to do Excel and all that. So that is really going to simplify life for very many people. It's going to improve efficiency for organizations and also lower their cost of training. The other thing you need to note is that conversational AI has attracted a very large pool of startups. There are very many startups in this space attracting a lot of funding because of the potential. But then the question is, why now? Why are we talking about conversational AI now? Why are we talking about chatbots now? Yeah, chatbots are essentially chat robots, intelligent ones. The first one is demand. We've seen that there is, for example, in the space of contact centers, there's a lot of pressure for companies to lower operating costs. And one of the easiest way in which these organizations can lower operating costs is deploying AI. I'll give you a very good example here at home. Who has ever heard of Safaricom Zuri? Anyone? Safaricom Zuri.
Yeah.
Now, Safaricom Zuri is an example of application of conversational AI. If you save the number 0722 000 100, 0722 000 100, and open WhatsApp and chat, that is a conversational AI system. You can reverse M-Pesa transactions. You can ask for your PIN change. You can ask for the PUK 1 and 2 change. You can query your balance. You can top up. You can stop transactions, everything. Now, if Zuri is able to do that, in how many years will Safaricom have 0 people in their contact center? In about 2 years or less, 1 year. In 2 years, they can eliminate everyone seated at their call center. Because Safaricom Zuri, not only is it now serving customers, it is also learning from whatever it is doing and whatever everyone in the Safaricom contact center is doing. So in very few years, in maybe 2 years' time, you would not need to call 100 and speak to an actual person. You'll be speaking to a conversational AI interface that will be available 24/7. It's not on shift like people. That will not occupy an entire warehouse, as is currently the case, where an entire warehouse floor is filled with contact center staff, very many of them. I don't know what percentage of their staff is contact center, but it's a huge number, a significant percentage. So that cost can be eliminated. So there's a lot of pressure from an organization to modernize their contact centers. And by modernize, I mean Zuri knows everything about every customer and all their history at its fingertips, compared to a call center agent who, when you call, they have to tell you, hold, let me check. Hold a moment as I transfer you to so-and-so, or let me confirm this data, this and this and that. That is eliminated. So responses are faster. Zuri is not a person, so they're always there on shift throughout. They'll always work 24/7. There's no waiting, as is the case right now, where you call and have to wait for long. Yeah. So in such instances, there's demand from the executive level that we need to lower our costs by using conversational AI. And that is also powered by the demand for self-service. Most people want to self-serve. If I go on WhatsApp and or Facebook Messenger, I should be able to do most of the things myself. If it wants me to reset my PIN, it will ask me a few questions and then immediately answer those questions. Everything is done. I don't need to talk to someone. Yeah, so that is a form of self-service. So I am essentially logging into the Safaricom customer care and business support systems and self-serving myself. But considering I've not been trained in logging in and using those systems, I will be unable to self-serve myself in terms of the traditional way. But with voice or conversational AI, I can be able to self-serve myself by simply saying what I need to say, and then the action is taken. The other thing is that the platforms, as I mentioned, are maturing. AI has advanced greatly in the last 3 to 4 years, and these advances have necessitated the application of the same. And one of the first and best applications is the use of chatbots. The other thing that we'd like to mention is, yes, we're talking about chatbots, but what was the history behind these chatbots previously? Now, the initial chatbots that started were basically scripted chatbots. This was essentially a system that was not AI powered. and they were simply scripts. And you say something, it responds back with a definite or a pre-programmed answer. It doesn't have ways of understanding your intent. It is simply expecting you to give specific answers. And in such systems, they don't give open-ended questions like, what do you want to buy? It gives you options. What do you want to buy? 1, maybe honey. 2, maybe ice cream. 4, maybe clothes. You choose out of those, then you respond. Then when you select honey, maybe it asks you how many kilograms. Then it gives you 1, 2, 3, 4, 5. Then you choose whichever you want to choose. Where do you want them delivered? Such and such. So if those systems had no way of handling a wrong answer or handling a different answer because they do not know intent. The difference between this old system and the new AI system is that in the old one, you needed to select, I need to buy honey. But in an AI-powered chatbot, if it gives you the option of honey, it gives you the option maybe of clothes and another option of books. And you don't say, I want honey. You simply say, I want the sweetest thing out of the 3. An AI system is able to understand what you've said, that it's honey you want because it is intelligent. It's not able to, it won't ask you, what do you mean? Or I do not understand your question. Yeah? So the systems have evolved, and the second one, of course, is called intent recognition, where you can recognize intent. As I've given an example, when you say, I want the sweetest thing out of the 3, your intent was selecting honey. Your intent was not selecting clothes because as far as we know, clothes are not sweet. So that is what is called intent recognition. And then this has evolved now to what are known as virtual agents. And a virtual agent example is the example I've given of Zuri. Safaricom Zuri is an example of a virtual agent, and they're able to offer things like customer support, triage in hospitals. Like now in most European countries, triage for COVID is done using a chatbot. It's not somebody meeting you. So based on the feedback that you give the chatbot, then it can know whether you're high risk or low risk, and whoever is handling you, how they should be dressed, etc. So we are currently at virtual agents, and we have started moving towards human-like advisors. And human-like advisors is something that will be available, or in some instances it's already available, where this system is able to interact with you in a richer way than a normal chatbot would. And we'll see an example of one system which is developed by Google, called Google Duplex, and how it's being applied currently in the market. We'll look at that. Now, when it comes to chatbot types, we have essentially 3. The first one I've mentioned is the FAQ chatbot, which basically has an FAQ type of approach, like the one I gave you, where it gives you 3 options to choose out of 1, or in instances where you ask specific questions, then it can be able to answer you. Yeah. So the questions have to be very specific, no ambiguity. Then virtual assistants. And virtual assistants is what we have been utilizing for the last 1.5 years or so. And this is now morphing into virtual agents, such as Safaricom Zuri. That's one example. Jubilee Insurance also has a virtual agent called Julie, and you can interact with it on Facebook. So when you go to Facebook and chat Julie, you can get quotes for insurance. You can find out when your claim is ready. You can find out about the processes of lodging a claim. You can find out the nearest branch to where you are. Very many things. All those things initially used to be answered either by a website or by calling an agent. So what Jubilee has done is that it has moved to where most of its customers spend their time in, that is Facebook. So Jubilee has said, do not leave Facebook to go to our website or call us. We will come where you are. And if you want to talk to us, you can talk to us still within your Facebook. Or if you spend a lot of time in Instagram or WhatsApp, the same thing. We can talk to you and do business with you wherever you are. Yeah. And that is what businesses are doing. Very many people are spending a lot of time on WhatsApp. And for businesses to leverage that, they need to use conversational AI systems. Any question up to there or any query? So we continue. Now, as I mentioned, a user can interface to a chatbot system by use of any method. Telegram, WhatsApp, Skype, SMS, Facebook Messenger, this is Slack, this is Google Assistant. So you can either talk to it, you can chat it, you can send a message to it, you can Skype it, anything. Yeah, so then the system itself, the chatbot system itself, or the chatbot framework itself contains the dialogue engine, which is very important. First of all, there's usually the channel connector. The channel connector is essentially when you connect to it and you say, maybe I want to find out about insurance quotes, then the channel connector will direct you to the insurance quote dialogue engine. Or if you say maybe you wanted to find out about your pending claim, to direct you to the claim engine, because those are designed as separate sub-entities of that system. So the system is now able to gather intent from what you're saying and know how to direct you. Because it's not automatic that when you go to Facebook Messenger and you're chatting Jubilee Insurance, you will simply say, I would like to follow up on my pending insurance claim. No, you might not do that. You might go there and say, you guys are useless. Then it will know, oh, okay, this person is not happy. So it can make a decision based on that. It can either ask you for further information, or it can automatically channel you to human intervention. It can channel you directly to a human being to talk to, yeah? Or it can still process that info further and gather more info from you and ask you. Maybe it can apologize first and then ask you what the issue is. Or maybe, and then when you say something, my claim, even if you say it in Swahili, nyinyi hata claim yangu hamja process. That word claim alone is enough. The rest are details. So it will know, it's about claim. So it will ask you, please input your policy number. Then you input. Then it searches and know, oh, this thing is still under the claim team. Let me find out what is happening. Then it gets that answer and it tells you, your claim will be ready on Wednesday this week. We sincerely apologize. And then you'll also go to the system and see, why is this guy angry? Because he was promised Monday and he's chatting Monday, 4 p.m. It will then say, we understand that we had promised you that it will be ready by Wednesday, but due to 1, 2, 3, this has delayed. And I assure you it will be ready by Wednesday, yeah? And so on and so forth. And this approach has been used by organizations. This approach has been used by organizations to design systems that, for example, can be used for business purposes, or in the examples I've shared where we saw a digital assistant in an organization, a virtual digital assistant can be used to query the company's ERP systems. The same can also be used by enterprises for customer engagement. In 2018, Domino's was one of the first organizations to incorporate conversational AI into their system. So with the use of the Amazon Echo, which is a very small speaker, which is like a Bluetooth speaker connected to the cloud and with Amazon Alexa in it, Domino's was able to engage their customers, receive orders, and do customer fulfillment using conversational AI. So let's look at an example. This is an ad by Domino's where they're saying order Domino's with Alexa. Let's see the capability of this system. And you need to remember that the system responding is the Amazon Alexa conversational AI engine. There is no human being involved other than the person who's talking to it. Let's watch.
Alexa, ask Domino's to place my quick order.
Okay, you have a 1 Supreme on Classic Crust for pickup at Hamilton QLD. With the Alexa offer, your order comes down to $12.95, saving you $3.89. Would you like to place this order?
Yes.
All set. Your order's been sent. You can track the status of your order anytime by saying, Alexa, ask Domino's to track my order. Thank you for using Domino's.
So, in that example, we've seen how Amazon, Domino's Pizza deployed Amazon Alexa to be able to take orders from customers directly. So in this example, we saw the use of intent and context. When this guy said, order me my usual, not his exact words, but the system has context that this guy last time ordered this, and he picked it at this point, yeah? And as you've seen, the system did not immediately place the order without confirming with the customer first. So there's a legal play there, because that is basically the customer agreeing to the terms and conditions when it says, would you like me to place this order? And when you say yes, it's like signing, yeah? So you cannot later claim that these things were billed to me, yet I didn't order them. So such a system now can be deployed by businesses. You can say, for example, if we deploy it, Alexa, I'd like to shop in Naivas. Then it will ask me what I'd like to shop. Then I can say maybe 2 rolls of China tissue paper, half a kilo of the yellow sunlight, maybe 2 bunches of vegetables, and so on and so forth. So I can give it what I need to order. Then it will place the order and maybe ask me whether I'll pick the order or whether I'd like it delivered by a courier. Then it will charge me. So what this portends for businesses is immensely powerful. The game currently is between Amazon and Google. Whereas Amazon has had a head start, especially in developing countries, where we've seen the statistics for adoption are very high. Google is now making its foray, and I think late 2018, they made Google Assistant available for free in every Android phone. So immediately, while Amazon are busy talking of being in 30% of American households, which is like how many? Americans are about 400 million. So 30% of that. Google is talking of now being available in over 1 billion Android phones. just like that. So with Google Assistant available in each and every phone, there's a huge potential for businesses now, even in Kenya, to today start from today. You can an organization can develop a conversational interface and say, you can order with us via Google Assistant. Then they'll say what you need to say. Maybe, hey Google, shop at Naivas, or hey Google, order from Java, or hey Google, I'm looking for a mechanic for my car. That's all I need to say, because maybe the system has context. It knows my car is a Toyota, or my car is a Volkswagen, or my car is an Audi. So this is the best garage for Audis, while this is the best garage for Toyotas. So that's what you're talking about. There's a lot of potential here in how businesses can utilize AI. And remember, this example is only somebody speaking in English. In the next 2 or 3 years, you should be able to carry out a similar conversation in whatever language, even the local languages, if we do it right, yeah? So the power of somebody being able just to speak to their phone or to their smart speaker and engage with businesses, or the power of businesses to engage with their customers where they are, in Facebook, in WhatsApp, or on their phones, is very powerful. This development is making websites become obsolete. Websites are becoming obsolete now because you can ask Google Assistant anything and it can answer you. Why do I need to visit a website? Yeah? You can place an order from any business that already has presence on the conversational interface and ask them anything that is available on the website. So when we say conversational AI is one of the most likely tools that can be used to bridge the digital divide, and at the same time bridge the digital inclusion gap, because digital divide is one thing, digital inclusion is another. Divide is where we say, my uncle in Mashambani does not have access to 3G network, so let us use universal funds to take 3G to him. So 3G arrives there, but the match he can do is laugh at memes forwarded on WhatsApp. Very least productive. Yes, it's making him happy and he can connect to a few people, but economically that is not very productive. But if we can be able to tell him that you can actually talk to any business in the country in your mother tongue and place orders wherever you are, and those orders will be fulfilled in your language, or you can search for anything on the internet in your mother tongue and you get the results, and the system can even respond to you in your language. Currently, Google, I think, is doing 90 languages. Amazon is at around 20 something. I can't remember the exact number. And the rest is on to include all languages into conversational AI. And if that happens, then all businesses will be able to reach a wider number of customers because of that, yeah? And the other thing is that this system consumes less data, of course, than browsing, if you dig deep and check. The other example which I gave was how we can use conversational AI to interact with ERP systems in the office. You can use a digital assistant, for example, to schedule meetings, to query information in the organization. Like I gave an example with a HR office digital assistant, staff are able to query many things that they would normally ask the HR assistant. When is my leave due? How many leave days do I have? My insurance policy, my medical cover, who does it cover? Does it cover this type of condition? Which hospital is open around me that is covered with my policy? All that info can be presented to the user by use of a conversational AI interface. This is a scenario of how Oracle shows how their digital assistant can be used to power the enterprise. So let's have a look.
With Oracle Digital Assistant, put the power of artificial intelligence at your fingertips. Let's take a look at how Oracle Digital Assistant can help transform any organization, department, and user experience. Trevor is a budding writer in his late 20s looking for a new job online. He logs onto Trend Global Marketing's website and browses roles that match his experience when a digital assistant appears. Trevor asks about openings, receiving an instant, conversational response from the assistant. Trevor expresses interest in future management roles. Then, a multimedia response offers a rich, engaging experience, showing Trevor some of the paths his career could take. When he decides to apply, Trevor is shown an Oracle Instant app, a rich media form, surfaced directly within the conversation, ideal for capturing structured data. He sends the application without ever leaving the messaging app. Meanwhile, Mai, a recruiter, gets a notification on her phone about 4 new applicants via Trend Global Marketing's talent management app, Global's digital assistant, to quickly accomplish a few tasks. Mai asks for a quick ranking of applicants, and the assistant responds, showing Trevor having the highest number of relevant tags, pulled from Trend Global's talent management system. Mai investigates further and confirms Trevor's background check is all clear. She can also interact with the assistant by voice and asks the digital assistant to schedule an interview. The digital assistant initiates a conversation with Trevor, offering interview times based on Mai's calendar, then notifies Mai when the interview is scheduled and adds it to her calendar. Trend Global Marketing's high volume of talent applications is streamlined, reducing cost and saving Mai and her team countless hours, allowing them to focus on more productive tasks. 1 month later, it's Trevor's first day on the job. The same digital assistant that helped recruit Trevor can also handle other business tasks, such as procurements. Unlike simple chatbots, Oracle Digital Assistant can bring multiple skills from various enterprise applications into one comprehensive assistant. The assistant offers 2 laptop options, but Trevor is interested in something else. Using the assistant's integration into the company help desk system, the assistant offers a seamless transfer to a live service agent. With the ability to seamlessly hand off unknown requests, Oracle Digital Assistant helps companies scale operations and respond to uncommon situations with ease. Susan picks up where the digital assistant left off to assist Trevor. When finished, she prompts a seamless transfer back to the assistant. Using natural language understanding intent detection and machine learning algorithms, the assistant accesses and leverages past behavior, providing hyper-personalized hardware options catered to his specific role and preferences. The assistant can even finalize the order without leaving the chat. The future is now. Transform your business with the power of artificial intelligence.
So as you've seen, conversational AI is not a theory that people talk about there. It is something that is already being applied in businesses. So Oracle is one of them. I think we all know Oracle's standing when it comes to enterprise resource systems. SAP is also coming out very strong in that area, where their conversational AI digital assistant interface is able to integrate into your into your systems. And the Oracle Digital Assistant doesn't need just to connect to Oracle systems. It can connect to other systems that, of course, compatible systems that can be used to interface the enterprise resource systems to the end users who are querying them. Same for SAP and other players. What this gives these organizations, like for Oracle Digital Assistant, this is a new revenue opportunity for them. With the organizations now predominantly going to the cloud, rarely are businesses buying, for example, Sun servers, which usually run Oracle databases, Sun servers. Rarely a business buying them. Somebody just get the Oracle license and run his Oracle from the cloud, maybe Amazon or Microsoft or IBM, wherever. And because Oracle is losing that market segment of selling hardware or in on-premise databases to users, the digital assistant is one way for them to remain relevant in this space. And it's one way for them also to adapt to AI. That AI has come, everything has gone to the cloud, our business model has been obliterated or severely damaged. How do we survive and move on from here? So these are ways in which they are doing it. SAP is also doing that with SAP HANA. SAP HANA is a different architecture of how SAP runs. And it's a very innovative and nice way in which they've done it, which leverages a cloud native approach and AI powered systems. I've given examples. I think I've covered this in terms of examples. In Kenya, currently we have the Safaricom Zuri chatbot, and you can access it via Facebook Messenger. You can imagine how many Kenyans are on Facebook or how many Kenyans are on WhatsApp. So businesses are reaching these people where they spend most of their time. People do not spend most of their time on company websites, rarely. Jubilee Insurance launched their Insurance Live Expert, which is accessed via Facebook Messenger, and it can respond to queries just like a customer service agent would do. And you see, this throws a spanner into the works, because remember, something like Zuri chatbot can scale massively and in real time. So majority of the requests, slowly Safaricom is trying to encourage people to use Zuri, because the more people use it, the more it learns and the cleverer it becomes. Yeah. For example, right now, you might have to say, when you're in Zuri, reverse my M-Pesa transaction. Then it might ask you for the transaction number. But in future, you might just say, reverse my last M-Pesa transaction. Then, of course, it has that info. Then it can reverse it if it's reversible, and tell you maybe the money will be back to your account in X hours. Yeah. Or I'd like to reset my PIN. Or I can't remember my PIN or PUK number. Then it can respond to you. The next phase of Zuri, of course, now everyone is chatting. It's now on WhatsApp. But the next phase will be Google Assistant or Alexa. And the next phase after that will be now in various languages. So all of a sudden, by use of AI, the Safaricom customer support is available in all languages by use of AI, not by recruiting people who can speak all these languages and putting them in a call center, but by use of AI. And this system can scale and is available 24/7 at nearly zero marginal cost. That is the essence of all this, that Zuri does not receive a salary. Zuri runs on the cloud and therefore is efficient and affordable to run. Zuri can serve very many customers simultaneously. Yeah. So that will lead to significant cost savings for an organization like Safaricom. But cost savings isn't the main reason why they are pursuing this. The main reason why Safaricom is pursuing Zuri is to enhance the customer experience. There's no waiting. The answers are instantaneous. No one is telling you, hold, let me log into the system and confirm. Let me transfer you to so and so on. So everything happens instantly. And the experience is amazing for the people who've used it. You can reverse M-Pesa transactions. You can And in future, you should be able to do M-Pesa transactions within Zuri. The next phase after that is that Safaricom Zuri will now also become a link to the marketplace. So my uncle in Ushago can simply now talk to Safaricom Zuri via either WhatsApp or via Google Assistant, for example, in his own language, and maybe place an order on the Amazon website, or place an order on Jumia, yeah, using natural language. So that's what you're talking about. So Zuri is not just an opportunity for Safaricom to lower their customer call center operation costs, and neither is it just an opportunity for Safaricom to engage customers better and give them a better experience, but it's also a massive business opportunity, because within Zuri, you should be able to order stuff like the Safaricom Masoko should be available within Zuri, where you can say, I'm looking for a phone. I'm looking for a phone slightly better than this one. Then it will look at what your phone specs are and maybe look at its stock and see what is available, and maybe remember this person bought this phone from us at this much, or this is Nokia, this type of phone, or this is a Techno, come on. Therefore, the next available one is this, and give you suggestions. And you can even look at your bonga points and say, you have this phone with your bonga points. That is the next phase. And that is how businesses are going to utilize artificial intelligence to power the next economic run that we are seeing currently. That the economy is changing, and the fact that the economy is being changed by AI, businesses need to utilize AI in real life scenarios. You know, a lot of AI has been very academic, or has been geared towards scaremongering about the dangers of AI and the robots taking over and all that. But AI can be used to power businesses. The second example, of course, is Jubilee Insurance Live Expert. By talking directly to Jubilee and not talking to brokers, we've had a lot of stories about brokers of late, where you pay, get even a sticker, insurance sticker, but it was fake, or an insurance certificate, but it was fake, yet you paid. So with this assistant, not only is Jubilee able to talk to customers directly in Facebook and in other platforms. I don't know whether it's available now in other platforms, but when they launched, it was on Facebook Messenger. And it can intelligently respond to queries and give instant answers. Today, if you call Jubilee call center and you give your insurance policy number, by the time that person comes back to you is another 30, 40 seconds. With Facebook Messenger, the minute that you press enter, that number is already being searched through the Jubilee databases and fed back to you on whatever status you are querying about. Yeah. So this is a very powerful means. Now I mentioned Google Duplex. Now Google is actually working towards creating what are known as digital assistant, virtual assistants, so that I create an assistant, a digital assistant to me, who is able to organize and plan my schedule and maybe take care of things that I easily forget. Yeah. If I have a virtual assistant online, and this assistant has access to my calendar, it has access to my activities today, what I'm going to do, and I talk to it frequently, or it has mastered my movement. Maybe it knows that every 2 weeks I have a haircut, and every 2 weeks I usually have a haircut at a certain salon, and I need to book an appointment. But for the last 4 months, I've been going to the salon or to the kinyozi at 2 p.m. But then this coming weekend, where I'm due for the salon, 2 p.m. there's an appointment. So, and I forgot totally. So let's see how Google Duplex, which is powered by AI, is able to run a digital assistant who is like a personal assistant, a PA. So everyone, the same way CEOs have PAs to run their daily activities, because they're very busy people. We're also becoming busy. And everyone is now having an assistant. The same way CEOs used to be chauffeured around in cars, seated back left. Everyone is seated in the back left of an Uber or a Bolt today. Yeah. So these technologies are democratizing what seemed to be out of reach for many. Digital assistant is, in fact, far more efficient than a human assistant. Let's see. This is Sundar Pichai, the Alphabet CEO. Alphabet, of course, owns Google, YouTube, and all the rest.
The progress with the assistant. As I said earlier, our vision for our assistant is to help you get things done. It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. You know, we are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
The progress with the assistant. As I said earlier, our vision for our assistant is to help you get things done. Call a plumber in the middle of the week. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now? Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex, It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
See, how may I help you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually, we leave here for like after like 5 people. For 4 people, you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
Again, that was a real call. We have many of these examples where the calls quite don't go as expected, but the assistant understands the context, the nuance. It knew to ask for wait times in this case and handle the interaction gracefully. Look,
Can't hear.
Can you hear me?
Oh, we lost you.
Can you hear me now?
Yes.
You can, eh?
Yes.
Oh, okay.
Yes, we can.
Okay. So as I was saying, conversational AI is being used to power businesses, and this approach has led to the growth of a new. There's somebody who is not muted, kindly. What is known as conversational commerce. We have been talking about e-commerce for very long. E-commerce has been the in thing. It's picking up, especially in Kenya right now due to the lockdowns. Very many people are ordering online. E-commerce has proved to be cheaper for businesses. You do not need to own a stall in town where you're paying a lot of rent, where the foot traffic might not be there depending on the location. So businesses are now going online, and there are so many, for those who shop online, there are so many boutiques on Instagram, and there are so many shops on Facebook today where you can buy things. Most of these shops is not like it's an actual shop in town. This is just somebody who runs it online. Maybe all that stock and merchandise is in his house in one of the rooms, and when they receive an order, they're able to fulfill that order and even deliver using the courier services, which are also now connected online using apps, yeah, such as Glovo, that is one example, Safe Border, etc., etc. The thing is that e-commerce is maturing, but because many businesses are now going online, you'd have, for example, somebody running a boutique on Facebook. that person needs to be there constantly answering to customers who are asking questions about the orders and all that. But a business can develop an AI-powered chatbot that is able to fulfill orders automatically. It is possible. The same way we saw with the Amazon, how Domino's is using Alexa. The same will be available to any business in Kenya soon, where a business will be able now to fulfill orders. Somebody chats and says, I'm looking for a trouser. Then, of course, the next question would be what size, what color. You give all the specifications, what material. Maybe you had previously purchased trousers or clothes from this boutique, so they know your taste. So they can be able to easily go straight to the point and know what your tastes are. The same way, if you shop frequently at a boutique and the owner knows you personally, they know your taste. In fact, when they get something, when new stock arrives, they know, this is the kind of stuff that Tom likes. Let me just buzz him and tell him, kuna stock mpya. None. So the AI system is actually able to do even that. So I can specify the trouser, the size, everything, the material, and even where it can be delivered. And soon we will have M-Pesa integration. That is the next phase of M-Pesa actually, integrating to this system. So I can say, okay, I choose the first trouser. Then it says this trouser is 2,500. Would you like to pay with that via M-Pesa? I say yes. Immediately, the system will connect to M-Pesa and just give me the point where I'm inputting my PIN, and I'm done, yeah? And the order is delivered. So this is a boutique that is running without the owner being there, without the need for like 5 members of staff to serve customers coming in. All of them are being served online by a chatbot, and their requests are being fulfilled online in real time. Orders are being delivered via courier, yeah? When you talk of a marginal cost economy, that's what we're talking about. This boutique, by the fact that it's nowhere in town, I'm not paying rent, I'm not paying fare every day to go there, I'm not paying staff, I'm not paying county fees to own a shop in town, I'm not paying the unjustified goodwill that businesses have been charging in Nairobi for new businesses. I'm not paying any of that. So my running costs are low. Because my running costs are low, you've lost me again. You can be able to offer the same trouser for maybe 2,500 shillings, whereas the same trouser in town in a shop would go maybe for 4,000 shillings because they are covering their other operating costs. So technology is making things cheaper. And when we say it's making things cheaper, this is what we mean. Right now, you can be able to place any order from any restaurant using the Glovo app or the Jumia Food app. You can order food from Java, from Trattoria, from everywhere, and it be delivered to your house. What is happening in America now, most of these restaurants are no longer even opening sitting areas. So it's a restaurant, it's known, big restaurant, Java and all, but I'm using Java because a local example that uses e-commerce. Not that it's the best, but as an example. It exists as a brand, but does not own any physical restaurants. They own what are known as kitchen warehouses, where it's one large warehouse where all the food is cooked and all deliveries are being delivered from there. But they're selling that kind of quality that customers are used to. So that significantly lowers the cost of operations for most of these businesses. And most of these businesses, after this COVID lockdown, especially restaurants, they are realizing we can actually survive without having an actual restaurant where people actually sit and eat. And many people have now realized that I can actually run a restaurant from my kitchen, where if somebody places an order, I have 2 hours to cook it and deliver it, and I'm able to meet that. So slowly, the ability of people to run restaurants and compete with established businesses They're gaining that thanks to technology. Yeah. And businesses are leveraging these technologies to reach customers and engage with them. And as I've mentioned, Google in about 1.5 years ago made the Google Digital Assistant available on all Android phones. Every Android phone has a Google Digital Assistant. And it's a powerful tool, as we saw last time, that you can use it for many things, not just even in business, even in normal life. Like, for example, I'd like to know whether it will rain here, where I am this evening. For me to know that, I need to go to various, maybe open a weather app. But with Google, just listen to this conversation. I hope it will be audible. I hope it will be audible. Hey, Google. Will it rain today?
We can't hear the feedback.
Oh, you can't hear it? Oh, just hold on. Hey, Google. Hey, Google. What's the weather like today?
Today in Nairobi, there'll be thunderstorms with a forecasted high of 68 and a low of 55. Right now it's 66 degrees and mostly cloudy.
Will it rain where I am today?
Yes. Today in Nairobi, there's a very high chance of scattered rain throughout the day and continuing through the night.
And that's it. So by use of Google Assistant, I've been able to know the weather and whether it will rain today where I am, and it's given me the probability without opening any app. I essentially do not need my phone screen. So when I say that conversational AI is providing a new user interface, that is what I mean. That users are able to interact with systems and apps, traditional apps, and engage with with businesses, and businesses to engage with customers using voice. That is what I mean. And we saw the example of Alexa, where you are able to place orders online using your voice. Yeah. And by Google Assistant being available in over 1 billion phones, and Google leading the way in as far as addition of more languages is concerned on this platform, businesses will in no time be able to run their businesses and engage customers using Google Digital Assistant. Now the question that comes in is, how will people be able to identify business one from business two? Like, for example, if I say, hey Google, order pizza, will it order from Pizza Inn? Will it order from Domino's? Will it order from Pizza Hut? What happens? That is where now skills come in. A skill is like an app. When you talk of mobile apps, like when you talk of the Jumia app, when it comes to voice, we talk of skills. So when that guy said, place my order for pizza, yeah, a business like, let's say Pizza Inn in Kenya, can register skills. So that if I'm in Kenya and I say, hey Google, order pizza, or hey Google, I want pizza, Pizza Inn business will already have paid for those keywords: order pizza, pay pizza, or I want to eat pizza. Yeah. But then therein lies the problem, and that is where now regulation comes in. Do we allow a business to use a generic word such as order pizza to direct traffic to them? The regulator can say no. Let businesses use specific business identifiers like order pizza from Pizza Inn. So that order pizza does not directly take you to Pizza Inn. When you say, hey Google, order pizza, it will give you options. Or based on context, it can know this guy actually likes Domino's pizza. So let me not waste time asking this person what they want unless they change their mind. So when I say, hey, Google, order pizza, it will know that this guy likes pizza from Domino's. That's where I'm going to order. Or this guy likes pizza from Pizza Hut, and that's where I'm going to order. So regulation comes in terms of such areas now. We come and say that business is moving to conversational commerce. How do we regulate this to ensure that we lower barriers to entry, we ensure that it works for the people? For example, refusing businesses to register generic words as skills is one way that conversational commerce can be regulated. Like if I say, hey, Google, I'm looking for a mechanic, Stands Auto Garage should not be the one responding to that. Yeah. If I say, hey, Google, I'm looking for a mechanic rated 5-star or maybe 4.6 star and above, then maybe Stan's Garage, which is rated at 4.7, might be the first to respond. Yeah. So that's the area that the regulator needs to look at and say that conversational commerce is taking root in Kenya. How do we ensure that it works for everyone? Because all of a sudden, we might find ourselves as a country where somebody says, hey, Google, order. The minute you say order, you are taken to Jumia. That is a problem. So Jumia, for example, I'm using it as a case, should not be allowed to register a skill called order, because order means ordering anything. So all businesses should enjoy from that, hey, Google, order XXX. Yeah. It shouldn't be allowed when you say, hey, Google, order, immediately it assumes you're going to Jumia. And whatever you will order will be from Jumia. When you say, hey, Google, order sports shoes, it shouldn't directly take you to Nairobi Sports House. Unless I say, hey, Google, shop from Nairobi Sports House, or hey, Google, order sports shoes from Nairobi Sports House, then it can do that. But if I don't do that, regulation should prevent the developers of that skill from directing very generic key phrases to businesses. Yeah. As I've mentioned, conversational AI has a huge potential. We've talked about how more languages can provide a new user interface. We've just talked about conversational commerce. We've briefly mentioned digital assistants, and there are new ways in which books and audio entertainments are done. Right now on Amazon Alexa, you can be able to listen to books or read books or interact with books. Amazon Alexa has storybooks for kids that are interactive. A story reaches somewhere where the fox wanted to do something, but then he could also do something else. In traditional storybooks, it was only one way. You follow the story the way the author wanted it. But with the conversational AI, the storybook in Amazon Alexa can ask the kid, would you like the fox to cross the river or go around the mountain? Then the kid can say whatever they say, mountain, or go around the mountain, or even say go around. Or the kid can say not cross the river. Of course, not cross the river means go around the mountain. And the story continues that way. Then it reaches a point where now the fox maybe needs to make a decision, A or B. Then the child is presented with the opportunity, or even the reader, it could be an adult, not necessarily a child. It could be a very interesting adult story. And the listener is presented with an opportunity to direct the story. So I might listen to the same story about the fox who traveled to Mombasa, but the adventures along the way are very different from me based on the choices I made along the story and the prompts. And to somebody else, the story might be very different. In my story, maybe the fox went by foot. In another story, maybe there was an option to go by SGR or something. You get it? So that is the power that conversational AI is bringing, not just only in commerce, but even in literature, even in entertainment. There are riddles that are online today. Even in Safaricom Zuru, you can tell you a joke, even in Google. Let's see. But for Google, it's very rudimentary. Hey, Google, Tell me a joke.
How do mountains see?
I don't know.
They peak.
Oh, they peak. You see, that's a joke. Tell me another joke.
Why can't a bicycle stand on its own? It's too tired.
This is just rudimentary. Now it can move further to riddles, to puzzles, to very many possibilities, even in academic areas. The thing that I needed to speak on slightly more is digital assistance. Now, there's a challenge, or there are some fears that digital assistance is one of the ways in which very many people will lose relevance in their work. Yeah. And we've seen in the form of the front desk, customer care already, digital assistance interfaces are replacing very many frontline customer care workers. In HR, it's also happening. Digital assistants are replacing very many people in HR in organizations today, because all what a HR assistant used to do, answering day-to-day queries for staff. When is my policy expiring? What is the limit of my maternity cover? Which hospitals covers? When am I due for leave? And induction, for example. Induction can be conducted using a digital assistant. You don't need somebody to be seated down taking staff through induction. What is happening is that digital assistants, there's actually an organization online, I can't remember the name, but it actually sells and designs digital assistants in the workplace for businesses. So an organization such as yours might decide we want to replace our HR assistants. Sorry, if you're an HR assistant and you're listening to this, apologies, but we want to replace our HR assistant with AI. This company will sell you an assistant who will then be integrated into your systems and into WhatsApp, into all that. We also do that, by the way, but not to the level of that company. That company is a bit more advanced. What we do is integration of the system to the backend systems, for example, for small businesses. But this digital assistant is now able to do very many tasks. And who knows, in the next 5 years, it is estimated that these assistants will become even smarter and more reliable than actual workers, to the point that this assistant is available 24/7. There's no salary for this assistant, and their feedback is instant, and they can scale. In that, one assistant can, for example, if you have a multinational like Unilever, they do not need a digital assistant in each and every country for HR, just one. And you replace all the digital assistants in the operations across the globe. That one digital assistant can answer any query based on your location. If you've saved a Kenyan number 0722 something something on WhatsApp for that digital assistant, then your questions and answers will be in the context of Kenya and Kenyan law, etc., etc. Yeah, and there's fear that as many organizations employ these digital assistants, they will end up replacing actual people from jobs. So that's also another talk of regulation. And when you talk of regulation, there are so many areas other than that. And the first one is AI-powered cybercrime. There was a story the other day, this touches on the president, I might be a bit careful there. There was a story the other day where a businessman was arrested for faking the sound of our president, the voice, and calling one of the big business magnates in Kenya. I think it was Merali, and some money was lost. There was another case where a chief financial officer I think in Europe or US, I can't remember. Can you hear me?
Yes.
Okay. So this chief financial officer received a call from his CEO who had traveled, and this CEO had given him instructions on some money to be transferred. This is actually a real case. And this guy obeyed those instructions, transferred the money and everything. only later to realize that it wasn't the CEO calling, and the CEO did not even authorize any transfer of money. When they dug further to find out what happened, it was an AI-powered voice that had been trained by these guys to speak exactly like the CEO. Exact. It had been trained on his speech. You know, somebody speaks and you know, that is fun. So because there's a way people usually speak. Maybe they add a lot of or they have a lot of pauses in their talk, or they mix words in Sheng and Swahili and all that. So there's a mannerism in which somebody talks that you might not even doubt that this is AI generated. So AI-powered cybercrime is something that is coming to the fore. There is also AI-powered cybercrime in the form of deepfakes. Who has heard of deepfakes? Let me show you a video of deepfakes, and then you will tell me. Just hold on. So deepfakes is a system where a video, you know, the way people edit pictures, you can edit a picture, maybe a picture of Michael Jordan in his basketball gear, remove that head and put my head. Yeah, that is very rudimentary. Now, it is possible to use AI to edit videos to look like it was that person speaking. Yeah, yet it's not. Movement of mouth, facial expressions, everything. So there's one that was created some years ago, which showed Obama created saying something using deepfakes. So let me just, is an advert. Yes. Skip that, so long. So this video was actually made using Obama. That was not Obama saying that, by the way. That was AI.
It got me thinking about my full-time employees and their ability to survive on $8 an hour in New York City. And foremost in all of our minds has been the loss and the grief felt by the people of Orlando. Most of us don't get our health care through the marketplace. We get it through our job or through Medicare or Medicare. And what you should know is that thanks to the Affordable Care Act, your coverage is better today than it was before. Women can get free checkups, and you can't get charged more just for being a woman. To give his employees came together to pass a common bill that would boost America's very, very hard times.
Some progress, at least within the small confines of the legal community. I think it's real important.
Here we go. President Barack Obama, when you're giving a speech,
So look
make
at
sure
this
you
guy
use
talking and then using
a lot
AI
of
to put it on Obama.
America's businesses have created 14.5 million new jobs over 75 straight months.
We're developing technology. Every technology can be used in some negative way, and so we all should work towards making sure that it's not going to happen. And even one of the interesting directions is that once you know how to create something, you know how to reverse engineer it. And so you can, and so one could create methods for identifying edited videos versus real videos.
So that is a cause of concern, especially like here in Kenya, where we are moving towards elections. Somebody can share a WhatsApp video of a political aspirant saying something, and you look at that video and you're like, yes, this guy said it. That's actually his voice. Look even at his mouth moving. It's in sync with what he's saying. This person said this. And it can cause a lot of problems. WhatsApp groups during political times, you know how they are used and misused. So AI can be used to generate such videos today. Yeah. AI can be used last year, I think during the last election, there was a video, Morgan Freeman. there was a video where allegedly Morgan Freeman was talking about the ODM elections, but it wasn't him. It was all fake. Yeah, I don't seem to find the video here. But the point is, AI can be used to generate fake data, like we've seen, fake conversations that never really happened, and there's a danger in that. So how does the regulation come in to ensure that AI is not used in negative ways, like we've seen there, to maybe cause political tensions, maybe to defraud people, or maybe to misinform people? Because somebody can generate a video of me talking negatively about person X and then share that video with person X. But I didn't say that. I didn't even utter those words, yeah? But it looks so real that it's believable. So that is one way in which AI is being misused. The other thing which regulation needs to look at is conversational AI economic effects. We've talked about AI-related job losses, for example, in the side of customer care. And for example, what would be the rights of digital employees? You might wonder, why do they need rights? There might be some rights in as far as employment is concerned. Yeah? Can a digital employee be taxed? That is something that KRA might be interested in. That yes, you've replaced the entire call center, but for every transaction that Zuri does, we'll assume that is a human being, and this is the tax we want. Those are things that need to be discussed. I've also talked of copyright and intellectual property in voice skill names. The refusal by the regulator to register generic skill names, like for example, order. That shouldn't belong to any organization, because many businesses will depend on that word to reach their customers, for customers to reach them. If I say order, it shouldn't take me straight to Jumia. If I say order pizza, it shouldn't take me straight to a particular pizza supplier maker who has paid for that. There should be some level of control on that. And that also calls into the business ranking mechanism and fairness. If I say order best pizza this side of Uhuru Highway, what ranking should be used? Is it in terms of the number of pizzas sold? Is it in terms of the number of ratings, 5 stars or 4 stars that are rated on online? Is it in terms of what factor? Yeah. So that is also an area of regulation that needs to be paid attention. And then the other area is privacy. I've mentioned privacy severally in this presentation, where we see that data used in AI training or machine learning or in big data analytics can be abused by businesses sometimes. If it lands in the wrong hands, can be misused by people with other intentions. Yeah, the common example I've been giving is the 3 data sets from my Fitbit. Those 3 data sets, maybe a provider collecting them. What would be the rules around that? Yeah, so we need to look at now data protection laws. How do we modify the current existing data protection laws to incorporate this new aspect? So those are things that can be discussed. And it is very important to realize that this is not just a one-day discussion. There's a lot. We can even have a session, if you guys are ready, maybe next time, where we can have a session on the regulatory front of all these technologies. So that don't just talk about SDGs and these technologies per se, but the entire presentation is about this last slide, yeah, and ways to identify, ways to modify the regulatory framework and all that. And that will enable us as a country to be able to utilize this technology as well. Because if we're not careful by there, like for example, that deepfake example, it can easily be misused by politicians to to stir strife, because all of a sudden my political opponent's party leader is here talking trash about my political leader, yeah, and then I'll be in trouble, or the politics will be very highly charged. So to conclude, I think it is critical that we relook at this again, maybe if you have time, in another session or another forum. But artificial intelligence provides us an opportunity to change the way we live and work. I think I'll stop there. Are there any questions so far on what we've covered in as far as big data and artificial intelligence is concerned? Questions, comments? So do I assume that we were following and we've understood based on the presentation, big data analytics and how we can utilize big data, and how conversational AI is now becoming a mainstay of our many interactions with the digital world? That the same way we interact with the people around us by talking to them in a natural language, it is the same way that we'll now be interacting with the digital world by simply talking to it. It will be either be an assistant on WhatsApp, it might be on Alexa, it might be Google, you talking to your phone, it might be Cortana on your Windows, it could be anything, yeah? So in future, you should be able to say, order pizza. If you're closest to your computer and it's Cortana, then it will respond. If you're closest to your phone and it's Google, it will respond. If you're close to your Alexa and you say, hey, Alexa, order pizza, then it will respond, and so on and so forth. So if there's no question, I think we can close there, and thank you very much.
Thank you too.
I'm still open. If there are any questions, I'm available on WhatsApp. You can chat me, or even tomorrow on any of the things that we've covered. Has this session been beneficial? I was just talking to myself.
It has been.
Okay.
Yes.
Karibuni sana. I think we can end there if there are no more further questions. Unless there's something Jonathan wants to say. I mean, Steve.
Thanks, Tom. I don't have much, but maybe just to thank you and thank the participants. Are we still there?
Yes, they're still there.
Okay, and thank the participants for going through the programs. Of course, I listened to the last part of the presentation, and myself, I found it very interesting. And also something else, the last slide, indeed, is there's a lot to be discussed here, especially to look at regulatory issues about around the AI. That to me is it's a very interesting part. Otherwise, from my end, I'm very happy about the presentation. And thank you very much, Tom, and everybody else.
Karibuni sana. So tomorrow we start with robotics and automation. It's also going to be very interesting. Your definition of what a robot is will change tomorrow. Thank you very much.
Okay, thanks.
Thank you.